Welcome, Shop Foreman Garage, and another rainy day in South Central Texas. The humidity is just stifling. It's been raining. Can't a guy just get a break? I mean, a guy can't even mow his front lawn. This humidity. Well, you know what they say, April showers sunk the Mayflower or something. Anywho, today we are looking at this 2021 Nissan Rogue. We are going to replace the blower motor. It's got a bad blower motor, and we're going to do a rear brake job, proper rear brake job on that. Also, that red 2018 Mazda CX-5, it's got a problem with its AC. Customer states the AC is not cooling, and I know it's got refrigerant in it, so we're probably gonna have to do some electronical diagnostics. I'm sure the pin tension's good in that. Nope, never got good pin tension. This Nissan Rogue needs a new blower motor. I know it needs a new blower motor because when the customer brought the vehicle in, the blower motor wasn't working. I went ahead and checked power at the blower motor, and I wasn't getting any power at all. So I traced back to the fuse, and the fuse was blown in it. So I put a new fuse in it. I then checked power at the blower motor, and I was getting good power, and as soon as I plugged the blower motor in, it popped the fuse. So that's the extent of the diagnostic. We're gonna go ahead and put a new blower motor in it and see what happens. This blower motor is it's not in a good place, and I'll get you in there and I'll show you what I'm talking about. It's like in the middle of the dashboard. Let's see if we can get in here. And this is where the blower motor usually sits in most vehicles, but this one is way up in there. I don't know if you can see it. I can't see it, but that's where it is. So you got to be careful if your blower motor goes out in your vehicle and you're driving down the road trying to turn your AC on and you're not getting any wind coming out of your vents because your blower motor's out. One of the first things you might want to do is just pop on the dashboard, see if the blower motor starts working, or if you can reach it, you know, down here, then you can go ahead and knock it, kick it, see if it comes on. If it does come on, then there's an open circuit, you know, inside the blower motor windings, and you know, usually you can hit it a couple times, get it working for a little bit until you need to replace it. But if you don't have the blower motor coming on, you don't want to keep driving with the blower motor in the on position, because if it is the blower motor, you can actually burn out your resistor. Some older vehicles especially use resistors to adjust the speed of the motor itself. Newer vehicles use a transistor or MOSFET, which works in a little different fashion, but those resistors are in the AC blower box, so that when the blower motor is running, it can cool them down, because resistance equals heat. And if you keep driving, your blower motor is not coming on, but you have your AC on, that resistor can get so hot it can actually melt and cause other issues. And then you got to replace the resistor and the blower motor and maybe even wiring. So you be careful about running your AC when your blower motor is not working. So just so you understand, this is what I'm talking about when talking about a blower resistor. Now this is not for this Nissan Rogue. This is actually a wiring schematic for a Kia Telluride, but they all work kind of the same way. And which, here's your blower motor, and it's getting power from up here. So on the ground side, they're putting resistance. So you got these like 3 resistors right here. So depending on where your switch is, of course, if it's switched to high, then this is going directly to ground right here. So if it's switched to high, then it is supplying all its ground to the blower motor. So the blower motor is going to be on as fast as it possibly can. Of course, if you switch to medium high, then it's going to go through this 1 resistor here. If it's switched to medium low, then it's going to have to travel through 2 resistors to get to the blower motor. So then if it's on low, it's going to have to travel through all 3 resistors to get to the blower motor. And each resistor takes away some ground. So the less ground you have, the slower the blower motor goes. And these resistors, they heat up. There's usually a heat sink on them, and they stick into the blower box. And if there's no air passing through because your blower motor is not turning on, they'll get so hot that they'll start melting, and they'll actually melt apart. They can even melt this connector right here, and then you're gonna have to repair the connector, replace the blower resistor, and then of course the main problem, which is your blower motor, if that's the case. And this right here, this is showing a rear blower motor, but this is not a resistor, this is a MOSFET or transistor. And it works in a little bit different fashion. In the way that it works, it allows a certain amount of ground to go through it, kind of like a relay or something like that. It also has a heatsink on it, so it needs to be cooled off too. I haven't seen a lot of issues with these, mainly issues with the blower resistor, but as far as the MOSFET goes, that's I don't know, some kind of magical electronical power or something there. I can't tell you exactly how it works because I don't know. Let's get back to that blower motor, get it put in. Okay, so Nissan wants us to take this dashboard apart so we can get in there and get that blower motor out, but I think that we can get it out without pulling all this apart right here. It doesn't pay that much to do this job, and I think that it would take a lot more time taking this dashboard apart. They even want us to take the center console out, so we're going to try and get in there and see if we can get it out without pulling all this. I'm pretty sure that we can. Okay, so I got you in there, just stuck up in there. You can see better than I can. May be able to use the app. That's what I'm trying to do to see what's going on. I need to take okay. Everything's backwards. I need to take this connector off. That's it. Get that out of the way. Now, I need to get that screw right there out. Should be able to get that screw out. And then pull the thing off. Okay, I should be able to. Should be a tab here or something. Need to grab and twist or something. Turn it. Push it. Let's see if I can figure this out. Okay, the hook is in here. And I need to push this piece or separate so I can need to separate these pieces right here. Of course, everything I'm seeing is through y'all's eyes and it's backwards to me. So I need to separate this from here and then spin the whole thing clockwise. That's what it says. I don't know how they expect you to get this apart. Is supposed to just press this with your hand? I don't see it. Oops, well, that ain't working. It's not gonna work like that. Maybe I can just show this in there. Of course, that's not working at all. Nope. Now my light's falling down. Nah, that's painful. Yeah, it shouldn't be this hard. Press this tab out and pull it down. Nope. There's got to be another way. I'm trying to not have to do this lying on my back because it's just not working for me. So that should. Nope. Oh, there it goes. So I just kind of hook it, pull it down. What? That was easy. Get this harness out of the way. It should come right out. Yeah. Comes right out of there. No problem. It's just coming right out. Yeah. Oh, now my camera's stuck. Okay. Stuffing things in the way. And it's easily just like, you know, coming right out of there. Just that easy. We got it. So there she is, bad blower motor and all. And there's that little hook that was stuck on there. Here's the new one. And this is a little hook right there that was causing all the problems. This one, as you can see, spins fine. This one, yeah, I mean, it can spin. I force it, but I mean, look at that. This one, so yeah, that makes me more confident this is definitely the issue. Let's get this new one in there. How's it going? I'm just hanging out. The cool AC. Got the blower motor in, and it's working good. It's nice and cool in here. I didn't want to bore you putting that blower motor back in. It's basically the same thing as taking it out, although it was easier having the camera up there and looking at the app on my phone to see where things were and stuff, but it wasn't really that bad. I just stuck it up in there, twisted it, put that one screw in, connected the connector, and it's done, and it's working good. So now let's move on to the rear brakes. We need to do a rear brake job. Okay, this is the on-car brake lathe. It's a Pro Cut 50 660. So we're going to use this to turn the rotors, and I will get this hooked up and I'll show you how this thing works. Okay guys, so I have the machine set up, got this thing centered the best that I could, and what I'm going to do is I'm going to turn these rotors. They're not that bad, but you should always turn rotors whenever you do a brake job. Don't just slap some pads on there, because you're going to cause yourself some issues later on. The pads are going to wear unevenly, or they're going to have noise, they're going to squeal, or whatever. Should always resurface the rotors or replace the rotors whenever you do a brake job. You don't want to just slap some new pads on some old rotors, especially if the rotors got grooves in them. Then you're just causing yourself all kinds of pain and suffering later on. So just make sure that you turn the rotors. If you're doing it at home, you can pull the rotors off and go to your local parts store. Usually they can turn the rotors for you, and they're not even that expensive. But we're going to turn the rotors ourselves with this on-car brake lathe. And so the first thing I need to do is I got it set up. I got this thing hooked up here, and I need to calibrate the machine. So got this thing locked down so it's not going to go twisting around or anything. So I'm gonna go ahead and turn it on. So Turn the machine on. And then it is going to go through a calibration, do an adjustment right here. And it will calibrate this and make sure that it's not moving like this. If it moves this way, then that's okay, as long as it's not moving this way. So we want to get it true, the machine true to where the rotor is. So, and it did its adjustment. It is way down, 0.0006. So no problem, it's as perfect as it can get. I'm going to flip this tray up so this will pick up any foulings or anything. And so what I want to do is back these off. I don't want them hitting the rotor, so I'm going to turn this thing, make sure that it's backed off both sides, and I'm going to turn this in. Just going to bring it in like that. And what I want to do is get this side, this back thing turned right here. So I got to have this loose right here and this, so that we can bring this back blade in. So I'm going to turn this until the back blade starts to touch. So I don't know if you can see that. Back blade is coming in. I just want it to just barely touch. Just like that. And then now I'm going to turn this one. So I'm going to lock this one down. And you can see it kind of moved a little bit. That's all right. Now I'm going to bring this one right here in and have it do the same thing, just so it barely touches, just like that. And I'm going to lock that one down and lock them both down, and I'll bring the thing all the way in. All the way through that rust and everything right there. Let's get as far down as we possibly can. And that should be good enough. It's way beyond where the actual brake pads touch. So we're going to cut from there out. So I'm going to release these again and release this back one, and I'm going to turn it just like 1.5 increments. Lock it down, turn this one. I'm going to move this one 1 increment. And I'm going to lock this one this side down right there. And then we have this chipper. Let's see if I can do this with one hand. So I'm going to stick this on here. Come on. No, I didn't get it on. Okay, hang on. Okay, get this into place. Just like that. Get that into place. And hit this button and it will start turning. There it goes. And it's going to slowly turn these rotors out. Okay, so as you can see, it did not exactly cut through all the way on this side. So that was just after one pass. We're going to have to cut it on both sides. As you can see, the other side is kind of the same way. So we're just gonna run her back down and move it one more increment on both of these, and then we'll cut it again. Okay, so that is a lot better. So we're good on that side, and of course this side turned out nice too. So now we can shut this off, and you can see how it looks. So we'll get on with getting the brake pads put on. We'll get this bracket put back on there, and we'll replace the pads. They weren't that bad. They're pretty getting thin on the inside, so on the outside rather. So we'll get this bracket put on, and then we'll get the pads on, and we'll mess with the caliper. Okay, so these are the new brake pads they got us. Import direct OE replacement. It's the premium. Fancy schmancy. Look at this fancy schmancy box. I wonder if you pay as much for the box as you do the pads. Aren't they quaint? Okay, so we got some hardware here. So I'm going to pull those pads off and get this hardware in, get the new pads in, and we'll go from there. Okay, so now we need to push this piston in. This vehicle doesn't have an emergency brake attached to the caliper. It actually has a drum. So this is actually a drum rotor combination, and it has drum brakes in here for the emergency brake or parking brake. And so this piston, you just push it right in. You don't have to worry about twisting it or anything. Those are for the calipers that actually have the lever in the back. So if you have a lever in the back, guys, you're gonna have to turn this in a different fashion than this. So I'm gonna use this thing right here to push this piston back into place. And once I get this thing going, okay, so there it is. Pushing the piston in, just like that. And then we get it into place. Okay, so that's one side down. I am going to get the same thing done over on this side, and boy, you're doing the same thing over again. Just so you know, this thing right here, one of the pieces just fell off. I got to stick it back on, but That's I don't know the official name for it. I call it a chipper, and what it does is it dampens the rotor, so that while the thing is turning and resurfacing that rotor, sometimes the rotor will start to vibrate and it'll sing and it'll start making a bunch of noise, really high-pitched noise, and that vibration, you can see it will make an imprint on the rotor as it's turning, and it will put this imprint all over the entire rotor, and it's really hard to cut that out. Once it's in there, it's hard to cut it out, and if you don't stop that rotor from vibrating, and you just put the pads on there with it like that, with that pattern on the rotor, it will actually cause noise whenever you hit the brakes. It will make a lot of noise. So you definitely don't want that rotor vibrating, which is the exact reason why we use this right here. So I'm gonna get this other side done real quick. Okay guys, I got the rear brakes all put together and everything all put back on. Now just gonna drive it on the road real quick and make sure everything's all right. Make sure whenever you do a brake job, any kind of brake job, front or rear, that you pump the brake, you know, a couple times before you put the thing in gear for the first time, because you've pushed those pistons into the calipers. Now you have to push them back out to meet the new pads that you put in there, and if you don't do that first, you put the thing in gear, you start rolling, you put your foot on the brake, and it just goes directly to the floor and you don't stop. And then you're there pumping the brakes real quick to try and stop before you wreck into something. So always pump the brakes after you do a brake job like this, before you start rolling for the first time. So I'm gonna take this on a test drive real quick, and then we're gonna get on that CX-5. Okay, so now we are working on this CX-5, Mazda CX-5. AC compressor's not turning on, AC's not cooling. That's what the customer's complaining about. I tried to take you on a test drive on that Nissan Rogue, but man, it is raining pretty bad, and the traffic was backed up. It's ridiculous. Anyway, let me catch you up on what is going on with this, what I've seen so far in this diagnostic. So I have my test light right here, and I got it hooked up to ground, and we're gonna check to see if we got power. This connector right here, this is a single pin right here that goes to the compressor clutch. So I need to start the vehicle, turn the AC on. The compressor clutch isn't even kicking in, but I know that it's got Freon. It has static pressure of 100 psi, so it should be enough to turn this on. So I'm gonna go ahead and check and see if we got power right here. So let me start it up. Start it up, turn on the AC. This engine is cold right now, but the AC is on, and I can feel the condenser fan is on. So I should be getting power right here, and I don't have anything, nothing at all. The light's not lighting up, nothing like that. So is my test light good? Yeah. So now we need to go on to the next step, and we're gonna check to see if we got power at the relay. So let me get that set up. Okay, so I am looking for this relay, and looking through all these relays and everything, and I cannot find AC compressor relay in this thing at all. So I went ahead and looked up the wiring schematics, like where the heck is this thing at? So here's the relay that I'm looking for, and it just happens to be in a special relay box that is right there. So that box, I'll show it to you exactly from my point of view, upside down. I don't know if you can see it. It's down in there, so I can't get to that. Who designed this thing? So what I'm gonna have to do is pull the bumper off and see if I can get to it. It just sits right down in here, and I'll do that right now. Okay, I got this one screw right, bolt, screw, I don't know, it's a bolt. That off right there. And I should be able to pull this open just on this side. Oops, I did forget one clip. It's always one clip. Somebody didn't take off. Okay. Just enough to get to this right here. This is what we're looking for. Come on, get out of there. Okay, that's it. That's what we're looking for right there. Inside this, so I can get it open. Okay, one of those is the AC relay. I have to figure out which one it is. Let's see, AC relay. It's not on here. This is not helping me. ADD fan, heater, accessory, where is it? Fuel pump. Okay. Back to the drawing board with this. Okay, so I got the, well, I got the wiring schematic here, but this thing right here shows this front harness, this little relay box thing, and see how it points front of vehicle, and right down here it shows AC relay is R1, and R1 is right there. So that's the one we want to check and see. Where's the rest of my, let's see what's going on here. We got the front body control module, and it is supplying power to this. Yeah, okay. So the front body, front body control module has power. It's supplying power, and then we're getting ground from the PCM. That should close this relay right here, which should supply power to the magnetic clutch of the AC compressor. So we need to check. We should have power in 2 spots on this relay right here. So let's check that out. Okay, so that is should be this relay, because this is the front. So this relay right here, I pull it out, and I got the vehicle running. I have the AC on. I'm not feeling it click or anything when I plug it in, and I do not see any kind of corrosion or anything. It looks really clean. So let me check and see if we got any power. We got power there. We should have power. Okay, we got power there. Power there and power there. So what we need is one of these is going to be the ground. One of them is going to go to the magnetic clutch of the compressor. Probably this one, so this is the bigger circuit right here. This probably goes to the clutch. This would be a ground coming from the PCM. This right here would be power from, I don't know if you can see that. It is coming on. Yeah. So this is power coming from the front body control module. So we need to see if this has a ground, and see what I can do, what I can try and do is I'm going to take my test light and I'm going to hook it to positive right here. Alright, so with the test light on positive, I can see if I have ground right here, and I do not. Okay, and this one, wait, I do have ground here. Hang on a second. Maybe this one's not the compressor. And the reason why I say that is because this circuit is unplugged. It's unplugged over here. So I shouldn't get anything there. If this is the compressor, then when I plug it in, this should show a ground. Let's see. Okay, let me plug the compressor in. Try to plug it in without getting my finger caught under the belt. That would be nice. Okay, so now compressor is plugged in. No. Okay, I'm gonna have to go back and look at this. Gotta find out what's going on here. Maybe this is not the right relay. Plug it in again. Not getting anything. No clicking, nothing. And this is the front. Okay. I'm gonna have to figure this out. Okay. So this is what I found. This right here has nothing to do with AC compressor. I don't know why. I don't know what it has to do with. And this is how I know, because I checked this fuse right here, this 7.5 amp fuse. It goes to the AC compressor, and it was missing. The fuse was completely missing from that. And now I put the fuse in to test this, and that has nothing to do with it. I don't know exactly what the heck this thing is talking about, but now our AC compressor is coming on. The AC is cold. It's cold. Yeah. So that just goes to show you. Always check your fuses first. Oh my God. So I'm gonna look into this. Maybe something happened. Maybe the fuse blew. The customer took the fuse out, and that's why the fuse is missing. But I'm gonna test on this and see if I can figure out why that fuse was missing and what was going on. No, it was all for nothing. I'll check it out and see what happens. Well, truth going on and being told, it's the next day. So I got caught up in the mystery of that diagnostics and just trying to figure out what's going on, and kind of figured out some, but yeah, there's still a mystery. There's a mystery that we'll probably never know. The world will never know. But there were some issues, and there's a couple of mistakes that I made too, and I want to go over that with you. So I want to look into the wiring schematics and the problem that we had, and see what I figured out. I figured out some stuff, but it's still a mystery. So I'll show you that. So this is what we're looking at yesterday. This relay box, this AC relay, and we're trying to diagnose this. Where we weren't getting any power to the magnetic clutch, right? So we're looking at this relay box, and according to this schematic, the relay box is way down here, and we got to take the bumper off to get to that relay box, and we did that. We pulled the bumper off, and this is what it showed. So it's showing that this R1 right here is the relay, AC relay, and R1 is right there. That is the relay that I was testing, and I couldn't make any sense of it. I was getting power to both circuits, and was showing a ground right there at the LG, that terminal C, even though the compressor wasn't even plugged in, which didn't make any sense to me. And so I was going back and forth trying to figure this out, and I couldn't get anything figured out. Well, you see this thing right here, it says seen from the terminal side, which means you pull the relay out and those are the terminals. So you're basically looking right down at it, and it shows the front of vehicle facing that way. Well, I found this schematic. It's the exact same thing. R1, right? LG. This is what we're looking at. Only look at this front that way. So what we should have been looking at is this one right here, right? And the same connector. We should have been looking at the bottom one, not the top one. This is the one we're actually looking at. This is the one I was trying to diagnose, and this is the one I should have been diagnosing the whole time because of that arrow right there. And it doesn't make any sense. If you look at both of these, this shows, this is for Skyactiv D 2.2, the Skyactiv 2.5 turbo, Skyactiv 2 liter, 2.5 turbo. It doesn't make any sense. It's basically all of them. This one right here, 2.2, 2.5, 2.5 turbo, Skyactiv 2.5 with iStop system. This doesn't have iStop system, doesn't have IE loop even, right? Yet this is the one that I should have been looking at. So once I got into this one, realized this arrow is in the wrong direction, point that towards the front of the vehicle, where in the direction we're looking. And it's one of my mistakes that I made. And it's not my first mistake, and I'm going to go over that with you and show you what that mistake is. Okay, so this is the first mistake that I made. This first part isn't really a mistake, but whenever you have any kind of electronical problems with the vehicle, you should check all your fuses. And instead of pulling each of these fuses out and actually looking at it, this is the best way to check fuses. You get your test light, make sure that the bus is actually powered up. In this case, I have the key on, and you can go to each fuse, to the end of each fuse, and check both sides. And you should have power on both sides. If you got power on one side but not on the other, then that fuse is blown. Okay, so usually that's what I do. I'll go through all these, check all the fuses, and not just the fuse that is associated with the system that you're checking, because you can actually have fuses blown that are associated in other ways to the system you're checking. So it's just best to check all the fuses first. The mistake I made, and in the bottom of this thing shows different fuses and their fuse locations and what the fuse rating is, how many amp fuse is supposed to be there. And it shows pretty much every single thing is filled out. There are some spaces that don't have anything, but there are cavities here with nothing in it. And the mistake I made is I checked all these fuses and they're all good, but when I came back, this fuse right here was not there. It was completely missing for some reason. That fuse right there is a fuse that powers up the relay that I was checking, and that is what the issue is with it. The fuse is just gone, and because the fuse is gone, there was no power getting to the relay, and because of that, of course, the compressor wasn't kicking in. So that's my mistake. I should have checked to see if the fuse was supposed to be there, and I just skipped right over it and then went on to the rest of the diagnostic, pulling the bumper off and checking the relay, which we should never done. If I would have noticed that fuse was missing from the first time, then I would have put a fuse in and we would have noticed that the compressor was working. So then comes the real mystery. Why is the fuse missing? And we contacted the customer and he's like, I have no idea. So one day you're driving down the road, your compressor works, AC works fine. The next day it doesn't want to work and the fuse is missing. And as far as he knows, nobody took the fuse out. So that's the mystery that we'll never know the answer to. But since the customer did order an AC service, we're gonna go ahead and you need to put the bumper back on. Gonna go ahead and hook up the AC machine, check all the levels and stuff, probably pull refrigerant out of it to see how much refrigerant's in it. I don't think that it's low, but we're gonna give the guy a good service anyway, because he's paying for it. So we'll put the bumper back on and get doing that right now. Okay, I have the AC machine hooked up right here. It's a 34788 NIH Robin Hair. And I'm gonna go ahead and turn this on. I got the hooking up the high pressure and low pressure hoses. And so we got static pressure right now it's sitting a little bit lower. Yesterday it was around 80 or around 100. So the static pressure is going to change depending on the outside temperature. It was a lot hotter yesterday, but I'm going to go ahead and recover the Freon that's in it and see how much is in there. I'm guessing this thing's not going to be very low. If it's just a little bit low, we'll just fill it with Freon and be done with it. Make sure the AC system is cooling really good. It's actually working good right now. And then if it is real low, then we will check for leaks. But I'm going to go ahead and get this system going and start recovering the Freon from it. Okay, so I'm going to hit recover. Do I need to save records? No. Recover. Do I need to save service? Okay, do not need to save. Okay, do not save service records. Yeah, we don't want to save service records. Connect both of the lines. I already have them both hooked up. Checking in that pressure, and then it is going to start pulling Freon out. Do you wish to take a snapshot? No, I don't. Okay, it is clearing. It is going to pull the Freon down now. Okay, so it looks like it recovered 0.306 kilograms. The minimum amount, I don't know if you can read that or not, it's 0.465 kilograms. It's not that much of a difference. And as far as I know, this vehicle has never had an AC service before. So I'm just gonna go ahead and charge the correct amount back into it. When I actually put the max amount, being here in South Texas, it gets really hot, and it's a good idea to put any extra that you possibly can. So I'm gonna go ahead and put the maximum amount. It's gonna be 0.515 kilograms, or it's like 1.5 pounds. So, or 1.1 pounds rather. So I'm gonna go ahead and do that right now. Okay, so I'm gonna go into charge. I don't need to pull a vacuum on it because it's already got a vacuum in it after the recovery. So I'm going to go ahead and just go to charge. Do you want to save records? No. Is this on a system electric compressor using POE oil? That's only for hybrid and EV electronical vehicles. So we're not doing the POE oil. So we hit no. And then I am going to put this to the maximum, which is 0.515. So 0.515 kilograms. And I am going to change this to charge on both sides rather than the high side or low side. I'm going to charge on both sides. It's just going to be quicker. And hit enter and go, and there it goes. Okay, so now it's asking if I want to take a AC system pressure snapshot. No, I don't care about keeping those records in the computer of this thing. Disconnect the high side and connect the low side hose and start AC on max. So I'm going to disconnect this high side hose. Just like that, and I'm going to turn the AC on. So what this is going to do is it's going to use the compressor in the vehicle to pull any extra freon that's in that low side hose out and put it into the system. So I'll put everything on max, and we will hit the button here, right here. And it is basically drawing down the freon that's in the hose right now. So now it's saying close the valve and turn the vehicle off. So close this. It's done. I can feel it. This is ice cold. And I'm going to turn the vehicle off. This vehicle also needs a blower motor, and it's cooling really good right now, but it does need a blower motor. The blower motor is working fine right now, but whenever I checked it out yesterday, turned the AC on, the blower motor didn't come on. I went down underneath there, way down here, and I popped that blower motor, and it just started working. So it has an intermittent fault inside the blower motor itself. So we sold the blower motor to the customer, and that part won't be here till tomorrow. So tomorrow we will put the blower motor in, and you can see the difference between putting a blower motor in the CX-5 as compared to that Nissan that we put in. A little bit easier, maybe. I don't know. That Nissan, it wasn't really that bad. If I had done a couple of them, knew exactly how to do it, honestly, you could get that blower motor out in less than a minute. and probably a minute or two you would have a new blower motor in there just right away. It wasn't really that bad. It was just hard to work up in there and see what you're doing. But so that's it for this one. I'm gonna get a new blower motor in tomorrow, and I'll show you how we put that in. Hey, how's it going? Got the blower motor. So I'll put the blower motor in and show you how that's done. Fairly easy, a little bit easier than that Nissan. So get you in here, you can see how this goes in. I gotta get this little panel off right here, and there she is, blower motor right there. Take this connector loose. See if I can get this thing under here. I got a couple of screws. Got one right there. And it's already coming off. See that? Easy. Ain't got no fancy hook. You gotta spin. That's it. I'm gonna grab the other one real quick. La-da-da-dee, la-da-dee-da, la-da-da-dee. Open the box. La-da-dee-da, la-da-da-dee, la-da-dee-da. Okay, there it is. Brand new. Go something like that. Just like that. Put the screws in. Let's get I can get these screws started. I can get 2 screws started and run her in there. If I can. This drill that I'm using as a power screwdriver is a little bit too long for this. And one more right there. That's it. Plug it in. Take this panel back on. In there, up there. Clip that in. And that is it. Got a really nasty, I don't know if you can see that. It's a really dirty cabin filter that the customer does not want to replace. So they like the air they breathe to flow through dirt and pollen. And that's it. So we're done with this. Go ahead and take her out on the road and see how the AC performs. And we'll do that right now. Okay guys, went on a test drive. Everything's good. The AC is cooling really good for the customer, and that's pretty much it for this one anyway. Please like and subscribe, and you might want to stick around. That Ford F-150, we're going to be pulling the engine out of that thing, and we will be rebuilding it, or maybe putting in a crate engine or something like that. We will definitely be taking that engine apart, so you want to stick around for that. So thanks for watching. I appreciate every one of you, and I'll see you in the next one.